we're just going to find the distance between 2 points using the distance formula. That's right there. I'll take these 2 points and I'll put them in. So basically what I'm looking at here is the distance is going to be equal to the square root of, well, basically x2 minus x1. So 4 minus 3. Now notice there's a negative in the equation and a negative on the point. So there'll be a double negative. So yeah, that's going to be plus, but I'll just write it this way at first. And then 0 minus 5. I'm going to put, I'll just write it out, 0 minus 5. And then we got to square that. Let's go ahead and extend this all the way out. Well, that's how it starts out right there. All right, and then once we have that, then we can go ahead and just clean it up real fast. So we're going to have the distance here, d, is equal to the square root 4 plus 3, which is 7, and 7 squared is 49. And then we're going to add to it 25, because we have negative 5, but negative 5 squared is positive 25. We'll just add those together here, and we'll get equals to the square root of 74. And the square root of 74 cannot be reduced, so that's the actual answer right there. You can put it in a calculator and get a decimal approximation, but that's the distance between those 2 points. Alright, again, we're going to be using the distance formula here to talk about verifying that the triangle is a right triangle and then find its area. Basically what we're going to do is we're going to find the distance between all 3 points using this distance formula over here. So if I want to look at the distance between A and B, then I'll have that distance will be equal to the square root of 4 minus 3, or 7, squared, which is 49, and then 7 minus 10, which is negative 3 squared, so it'll be plus 9. It's 3 squared. And we're going to get this thing to turn out to be, I'll make this the square root of 58. We'll leave it just like that, even if we can reduce it, because we want to just leave it as the square root of 58. And then let's look at B to C. Will be equal to the square root of 1 minus 4, which is 3. 3 squared is 9. And then 0 minus 7, 7 squared is 49. So hey, look at that, same as the one before. And that turns out to also be the square root of 58. We'll leave it just like that. And then finally, we'll look at A to C. Okay, let's see what that is equal to. It's going to be another square root here. And it'll be 1 minus 3, or 4. 4 squared is 16. And then 0 minus 10, which is negative 10 squared is 100. So we'll do that, and we can do this to come out to be the square root of 116. And of course, this of these 3 numbers, this one right here is the biggest, so it'll be the hypotenuse. So now we can just check to see, does the square root of 58, I think it says verify, so it sure does, the square root of 58 squared, that's one leg, that's a square. Let me redo that so it looks more like a square. This pen's a little strange still, 2, there we go, and then plus another square root of 58 squared. Does that equal to the square root of 116 squared? And the answer is yes, it does. So it is indeed a right triangle. And so we've answered the first one. We verified it. Yes, it is. And the sum of the squares of the legs of the hypotenuse are, well, it's 116. And then the area will just be the square root of 58 times the square root of 58, which is 58. So we get the area of a triangle. So the area will be equal to, well, the square root of 58, that's one leg, times the other leg, the square root of 58, divided by 2, because the area of a triangle is the base times the height divided by 2. And that becomes, well, the square root of 58 times the square root of 58 is just 58. And we're going to cut that in half, and that's going to give you 29. There you have it. Okay, next question wants to find the midpoint between these 2 segments, points, the midpoint of the segment joining those 2 points. And we have the formula here. Basically, if you look at it, it's just the average value of the x and the average value of the y. So we'll take the 4 and the 8, so we'll do 4 plus 8. Then we'll divide it by 2. That will be the x value. And then the y one will be negative 4 plus 4, which is 0, of course, but we'll just write it over 2. We turn out to get, well, that's 12 divided by 2 is 6, so this is equal to 6. And of course, 0 divided by anything is still 0. So 0, there's your midpoint. Couldn't be much easier. Okay. For this problem right here, we're going to find all the points that have a distance of 5 from this point with the next coordinate of 1. In other words, we have the point, let's see, what do we have there? Minus 2 and 3 is the point. So let's do that with, we'll take the point minus 2 and minus 3. That's the one we have right there. And then the other point is going to be x coordinate of 1 and y coordinate of we don't know, so y. And then we'll just use the distance formula on that. So the distance formula from previous example, 1 minus minus 2 will be 3. 3 squared is 9. And then y minus minus 3 will be plus y, or y plus 3, because it's subtracting a negative. Let me see if I can get that to draw right in there. Let's see if we can get this here. Yeah, it's going to be y plus 3 squared. Okay, that'll be squared. Okay, so if we go ahead and look at this, we're going to come up with an equation here. It's going to be, well, let's see. This part will be equal to the square root of, that's not 9 squared, since 1 minus 3 is 9. 9 squared is just 9. This should be just 9 inside here. Make that just a 9 in there. Okay, that's all it's supposed to be. Alright, so we have the square root of 9 here, and then we'll do plus y plus 3 squared. And this is supposed to be equal to 5, and that's the thing that we see from up there. The distance is equal to 5. Okay, let's take that equation. So then now that we have it set up like that, we have, well, we can subtract 9 from both sides to get y plus 3 squared is equal to 25, which means that when we take the square root of both sides, don't forget the plus and minus symbol here, we get y plus 3 is equal to both plus and minus 5. So we get the y coordinate over here is going to be equal to 5 minus 3 is 2, and the other one 5 minus negative 5 minus 3 is negative 8. I'm just subtracting 3 from both sides. Okay, so we get those two coordinates. Now don't forget to put them back in here. So the actual answers will be 1, comma 2 as a point, and then the next one will be 1, comma negative 8. All right, there's your two answers. Take a look at this problem involving the midpoint here. We have minus 8 to 3 is the midpoint, and this is one of the points. So if I set it up there, I'd have it basically looking like this. Point 1 is minus 7, comma 4. And then we know that this is point number 1. And we know the midpoint right here is negative 8, comma 3. And then we want to know point number 2 right here, which we'll call x and y. And then we can use the formula by saying that minus 7 plus x divided by 2 has to turn out to be negative 8. And also we have, well, let's just go ahead and solve that. That means that minus 7 plus x has to be negative 16, or x has to be equal to negative 9. Okay, so we have our first coordinate there of our midpoint, which would be negative 9. Now we're going to do the same for the y's. We know that 4 plus y divided by 2 has to turn out to be the 3 that's in the midpoint. In other words, you add these two together, divided by 2, like the formula says, and you get this point. So we know 4 plus y is equal to 6, or that y must therefore be 2. And now you have your answer of negative 9, comma 2. To write the standard form of these equations right here, we see that we have a circle, and here is the equation of a circle over here, if you want to take a look at that. And we have basically everything we need to put in there. We're going to have, it's going to be, let's do x minus 6 here. Let's see if we can get that, x minus 6. Because we're putting in the h here value as 6. Notice it's positive here, but there's a minus sign in there, and that's squared. And then we'll do plus, y minus 8 squared, and that will be equal to the radius squared to 100. And that is the standard form right there. That was easy enough because we just plugged it right in. Now to get to the general form, we just need to multiply it all out. So we get x minus 6 squared, which is x squared, minus 12x plus 36. And this will be plus y squared minus 16y plus 64 is equal to 100. That's just using the FOIL method on those. And then we just put it in the order of this. X squared plus y squared minus 12x minus 16y. And notice that's plus 36 and 64, which is 100, and equal to 100. They'll cancel, so it'll just be 0. And we're done. There's the standard form right there. Sorry, general form. That's the general form. Okay, if we want to find the standard form of this equation, we know the center is at the origin, so we can do the, from the formula from the previous example, we can just say, x minus the, well, I'll put 0 for a second because that's part of the origin, x minus 0 squared plus y minus 0 squared because 0, 0 is the origin. And that's equal to r squared, which we don't know just yet. And then we can clean this up to say that this must be x squared plus y squared equals to r squared. Okay, and then we can just plug that point in for x and y, so we get 3 squared, or 9, plus negative 6 squared, which is 36, is equal to r squared. So we now know that 45 is equal to r squared. So we can come right up here where it says r squared right there and plug it in. So our answer will be x squared plus y squared is equal to 45. There's your answer right there. And that's only just plugging in that point. 3 and negative 6 into 3 squared is 9, negative 6 squared is 36. Add them together to get 45. And then plugging it in. And you're done. Okay, so in this particular case, it looks a little weird with this word tangent. But basically what you have here is x. Just from the previous example, we have x minus 2 squared plus y plus 9 squared is equal to r squared. And you see the opposite sign, 2 and negative 2, negative 9, positive 9. That's how you do that. And then to find the radius, since it's tangent to the y-axis, that means use the absolute value of the x-coordinate. And if it was tangent to the x-coordinate, you use the absolute value of the y. You just switch them. So what is the absolute value of the x-coordinate? That's 2. So we have x minus 2 squared plus y plus 9 squared is equal to, well, 2 is the radius. 2 squared is 4. And that 2 is right there. That's the 2 that we're using right up in there. Because it says y-axis, we use the x-coordinate in absolute value. Had that said x-axis, what you do is y. But that's all you do. And there's the answer right there. So don't be afraid of the tangent thing. It's really easy to do. All right, a couple more here. We have the diameters of the endpoints of the diameter. So we need to first find the midpoint of those. So we'll use the midpoint formula. 1 plus negative 5 divided by 2 is for the first point, and then 4 plus 6 divided by 2 for the second point. That's negative 4 over 2, which is negative 2. That's 10 over 2, which is 5. So there is our center. So now we can write x plus 2 squared plus y minus 5 squared is equal to r squared. And of course, you see the opposite signs here between the minus 2 and the positive 5. Now all we have to do here is plug in the point, either one. We'll use 1 and 4, so we'll put 1 plus 2 squared plus, well, y would be 4 minus 5 squared is equal to r squared, and that's going to be 3 squared, which is 9, and then negative 1 squared is 1, so that's going to be r squared is equal to 10. And then we can just plug that 10 right back into that r squared right there. So we can write our equation as x plus 2. Let me do that a little bit neater. Oh, sorry about that. See if we get in there a little bit better. We get x plus 2. That's not a whole lot neater, is it? Squared plus y minus 5 squared equals to 10. And that's this 10 from right down here. Okay, I think we got one more after this. Okay, so we're going to go ahead and do the center and the radius. I'll do that by completing the square twice here. We get x squared minus 2x, and then y squared minus 4y is equal to positive 31. After I just move the stuff around, putting the x's together, putting the y's together, moving the 31 over there, and then we're going to add to both sides after completing the square. On this side we're going to add 1, and on this side we're going to add 4. So we'll put the plus 1 and plus 4 here as well. That's just completing the square. Half of 4 is 2, 2 squared is 4, half of 2 is 1, 1 squared is 1, and so on. This becomes x minus 1 squared. This becomes y minus 2 squared. Of course, there's a plus sign in between them, and then we have 36 over there when we add it all together. All right, 36 here. That's equals to, which tells me now I have the center and the radius right in front of me. So we'll say the center is at 1, 2. You can see that from here, and the radius is equal to 6. Okay, and then to graph it, you just go to 1, 2, and then out 6 in each direction. Should be easy enough to graph. Let's find the intercepts. We'll put in a 0 for x to get 0 minus 1. Right here we get 0 in for x, 0 minus 1 squared plus y minus 2 squared is equal to 36, which means that y minus 2 squared will be equal to, well, minus 1 squared is 1. Take that away from 36 and you get 35. And therefore we get y minus 2 equals to this plus and minus the square root of 35. Therefore the y-intercept will be y equals to positive 2 plus and minus the square root of 35. Okay, for the x-intercept we're going to do something very similar. For the x-intercept, we'll put in a 0 for y, so we'll get, let's see what we get here. We'll get x minus 1 plus 0 minus 2, those are both squared, is equal to 36. So then we'll get x minus 1 squared minus 2 squared is 4. Take both that away from both sides, you get 32 over here. And then x is equal to 1 plus and minus the square root of 32. Same way we did it last time. Okay, that should be enough to help you.